Hi, my name is Connor Hodgson and this is my Wwise sound design and implementation reel. So let's jump straight in and take a look at the ambiences. By using a variety of audio emitters around the world, we're able to build an immersive environment for our Stacko bot. Each emitter plays its own sound, from bees, insects and wind to rustling of bushes and machinery coming from the buildings. Using emitters like this helps us to bring the player into the 3D world. By setting up attenuation curves in Wwise, we can control the volume of each sound based on how far away Stacko bot is. Here I've used a max distance of 900, this value matches the radius of our radial emitter tied to the audio source in Unreal. We're able to manipulate the attenuation curve however we like by adding additional points along the graph. Here I've added a change at a distance of 600 from the sound source, where the attenuation changes from a linear to a curved ramp up. So let's hear the ambiences in game. Now, let's take a look at the footsteps of our Stacko bot. First we'll see how they sound, then we'll dive in and see how they're done. To start, I opened up each of the animations used for Stacko bot's movements and used anim notifiers to pinpoint the exact time in the animation I wanted the sound to play. In Wwise, I've set up switch containers that change what is played depending on which switch state is active in game. Here I've set up switch containers for the footsteps and materials. Within the Game Syncs tab in Wwise, I've created the relevant switch states and linked these to the relevant audio containers within the switch containers. Here we are looking at pitch randomization for the footsteps that play when Stacko bot is running. I've used pitch randomization to allow for more variation of footsteps and to help reduce repetition and player fatigue. I have also set up RTPC curves for both pitch and volume based on values I gathered from Unreal using ground speed variable, which controls the RTPC curve set up in Wwise. What this means is as Stacko bot runs quicker, the footsteps will shift up in both pitch and volume. Next, I went into Unreal and assigned the different surface materials from the Wwise materials switch container so that we can control what sounds are played depending on the surface type that Stacko bot is currently walking on. To make this work, I've used a line trace in the blueprint which detects the surface Stacko bot is currently on. Within the blueprint, we have both of the footstep anim notifiers, which we use to set the boolean variable, which determines whether Stacko bot is running or walking. This then fires into the line trace, which tells us what material we're on. Then, by using a branch node with a getWalking/running node connected, we can control which path the impulse follows to trigger the right sounds. Now if we follow the true branch, which would mean Stacko bot is running, we can see by using a set RTPC value node, which has the ground speed variable connected, we're able to communicate with the RTPC curve set up in Wwise earlier, which is set up to control the pitch and volume. Now at the end of the blueprint we can see a sequence node which fires into two post-event nodes. I did it this way so we could combine the footsteps with different materials to help convey a sense of heavy weight to our Stacko bot. My name's Connor Hodgson, this has been my Wwise sound design and implementation reel. Thank you for watching.